Hey guys, welcome to Students of Chemistry. We, as chemists and our dear physicists, always use the value of light speed in various calculations. You ever wonder how this value has been derived? I'm going to share you that interesting story in this video. Come on, let's get started. This story traces back its origin to 1610 when the famous astronomer Galileo Galilei discovered the four largest moons of Jupiter. It was Giovanni Cassini in 1688 who provided the accurate table of durations of these moons' eclipses. Ole Romer, who then started his career under Cassini in the Royal Chemical Society, was very enthusiastic in this field. He could also view only the four largest moons of Jupiter, namely Io, Europa, Ganymede, and Callisto. On calculating the duration of eclipses of moon, Jupiter will cast a shadow in the part opposed to sunlight. The moons entering the shadow and leaving the shadow can be seen clearly from the earth, which they call as immersion point and emergence point. They have always used Io as their reference because this moon is the innermost of four moons, and also its orbit is very close to the plane of Jupiter's orbit around the sun. But Ole Romer find a discrepancy in the moon's eclipses when Earth and Jupiter's distances varied. He found that from the position 1, the eclipse has been 11 minutes larger compared to that seen from the position 2. As Earth comes closer to the Jupiter, the duration of eclipse became shorter. He soon realized that this is because the distance is short for the light to travel from position 2. With the known values like distance of Jupiter from Earth, the diameter of Earth, and the duration of eclipse of Jupiter's moons, he calculated the unknown value of speed of light. Initially, he calculated the speed of light to be 1,33,000 miles per second, which is 2,14,000 kilometer per second. But the current calculation shows the speed of light is 1,86,282 miles per second, or 2,99,792 kilometer per second, which we simply call it as 3 into 10 power 8 meter per second. Hence, Romer's calculation was 25% off from current calculations, but nevertheless, it was very great for a first approximation. It also answered the most widely asked question of that time as to whether a light has finite speed or not. This calculation showed it is. These calculations were readily accepted by Isaac Newton, but not many scientists showed interest in this. Even Cassini pointed out the discrepancy in observations of the other moons were still not accounted. And unfortunately, Romer's findings were not universally accepted. But this doesn't stay for too long, as the English astronomer James Bradley came up with his accurate calculations in 1729. A story was strongly believed that when James Bradley was sailing in a boat in River Thames, he noticed the flag in that sailing boat turned its direction when the boat took a turn. He was surprised of this because there is no change in wind. He later came up with his idea that only the change in direction and speed of the boat caused the flag to change its direction. Soon, Bradley worked out the consequences of supposing the direction and speed of Earth in its orbit, combined with the consistent speed of light from the star, might cause the apparent changes of stellar position that he observed. He called it as the stellar parallax. Did Romer accounted the speed of Earth in its orbit? He could also given the accurate speed of light, which was then given by Bradley with his stellar parallax concept. Finally, Everyone accounted Romer's calculations and applied James Bradley's corrections, and we have our value of light speed now in our academic books. With this small information, I would conclude my video. If you like this video, please like, share, comment, subscribe, and hit the bell icon. I will see you guys in the next one. Thank you.